Hello. The topic for today is algorithms, the integers, and matrices. Algorithms are a set of instructions that we follow to perform some task. As you know, if you think about algorithms in that way, we follow algorithms many times in our daily lives. Suppose that you are looking for a book in your bookshelf. You need to see, are the books arranged in alphabetical or some other order? Yes or no? If the answer is yes, then you follow certain algorithm to find the book you're looking for. If the books in your bookshelf follow no order whatsoever, they were just randomly placed, then you follow a different algorithm. In discrete mathematics, this set of steps can be formalized and could be analyzed to determine how efficient these algorithms are and whether they will help you to achieve the task at hand. Let's take a look at a very simple example about finding the maximum value in a sequence of integers. We have 4 different steps. The first step is to set a temporary maximum. So you don't know, first of all, you don't know how many numbers you have in the list. And secondly, you don't know whether they are sorted or not. They may be in random order. So you have to look at all of them to determine which of them is the maximum value. So you start by looking at the first integer in the sequence of numbers, and you assume that this is going to be the largest of all. You have to assume that. And then on step number 2, you go to the next number in the sequence and then compare that number to your temporary maximum. If that number is larger than your temporary maximum, then your temporary maximum will be this new number. You don't know how many numbers you have in the sequence, so you need to repeat step number 2 as many times as numbers you have in the sequence. Finally, you will stop when there is no more numbers in the sequence. And at that point, the value that you have for your temporary maximum variable is the largest number in the sequence of numbers. So this is a straightforward algorithm, and it works. At some point it stops. It has an end. But to specify this algorithm, as you can tell from these 4 steps, it was kind of many things that you need to write. So to simplify things, we use what is called a pseudocode. So pseudocode is a set of conventions that you use to describe an algorithm. Now, there are different kinds of pseudocodes, and there are different conventions about pseudocodes. So the one that we'll follow in this chapter is the one that is outlined in the textbook. If you want to learn more about those conventions, you can go to appendix number 3, and everything is in there. However, that's not necessary, because as we move on with the notes here, I will tell you what each instruction is, and most of the time you're going to find them quite intuitive, because they are very similar to plain English, as we will see. So here we have an algorithm. The description is like it finds the maximum element in a finite sequence. So first you have the procedure. So that means that this is the name of the function, of the algorithm. The algorithm is called max. So when you need to refer to this algorithm, you will call it max. And furthermore, the algorithm is going to take an input. As in the previous example, the input was the list of integers. So here the list of integers is denoted with these literals. So from a sub 1, that's the first integer, up to a sub n, that's the last integer in the list. And you're specifying here that all of these numbers are of type integer. So this line of the pseudocode is telling you the name of the algorithm and what the input of the algorithm is. On the second line here we have this is what we call the temporary maximum in the previous example with plain English. So we call this variable max, okay? And we assign the first element in the list, a sub 1, to that temporary maximum. And as we said before, since we don't know whether the list is sorted or not, we have to assume that the first element in the list is the largest until you find another element which is larger than that one. Okay? Then what we had before as the step number 2 and 3, those two steps are here. So step 2, and this is kind of in reverse order, but step 2 is this little guy here. If the maximum or the temporary maximum variable is smaller than the next element in the list, then that element has to be called the maximum. Okay? And then step number 3 here in our previous example is given by that instruction, the for loop. So loops in pseudocodes allow you to repeat a set of instructions over certain conditions. In this case, the condition is to repeat this instruction if, okay, for values of I from 2 to n. So every time you execute this instruction, you increment the value of I by 1. So eventually the value of I will be equal to n. At that point, the algorithm will end the loop, the for loop. And at which point, the value given to the variable max would be the maximum value in the list. Okay, so from this algorithm, and we can identify some properties of algorithms that are generalized for every algorithm. The first thing is that you need an input to the algorithm. The input is given here. The second thing is that the algorithm must finish at some point. So the algorithm is going to finish, and we know that as a fact because you go and repeat this for loop for I equals 2 up to n. So eventually the value of I will be equal to n, and that would mark the end of this for loop and the end of the algorithm. And finally, the algorithm works. So those are basically the characteristics of an algorithm: an input, a finish, and it works. Okay, so those three are essential characteristics so that an algorithm can be called an algorithm, right? During the synchronous session for the course, we'll do the example. Let's take a look at some sort of algorithms called searching algorithms. And as the example that I gave before is that suppose that you're looking for a book in your bookshelf. So how are you going to proceed? It depends. If the books in your bookshelf, you know they are in alphabetical order, then things become much more easier. However, if there is no order for the books in your bookshelf, then you have to basically just go through the whole list of books until you find what you're looking for. And this is very similar to the previous algorithm where you had to find the maximum value from a list of values, because you have to go through the whole list of values to make sure that you have the maximum. The slight difference here for the linear search is that you don't have to go through the whole list. You only have to go until the point where you find the book you're looking for, right? Makes sense. But if the book is not in the list, as a consequence, you will have to go through the whole list of books in your bookshelf just to realize that the book you're looking for is not there. So let's take a look at this algorithm. The name is linear search, and then we have the input. First you have X. X is an object. In this case, X is a book. And then you have a collection of distinct objects. They are called A1, A2, up to AN. This is the input to the algorithm. So the algorithm proceeds by assigning the value 1 to variable I. So this variable I is the one that is going to help us navigate through the elements of to the collection of objects. As you can imagine, we're going to use this value I as the subindex of the collection of objects in the input. Okay, so we need a loop again. This time we use a while loop. The while loop will execute that instruction while this condition is true. So initially, when I is equal to 1, let's say you have 10 books in your bookshelf, then I is equal to 1, I is less than 10, and the book that you're looking for is not the first one in your bookshelf. Then this condition is true. Remember, it's an AND. And since the condition is true, then you execute this. I is equal to I plus 1. So that means that you come back here and then reevaluate that expression with the new value of I. So the second time around, I is going to be equal to 2. 2 is less than 10. And then you check if the book you're looking for is not the same as the second element in the bookshelf. If the answer is no, then you continue. So what's going to happen when you have a match? When you have a match, the element you're looking for will be equal to that book, right? So this condition, the whole thing will become false because we have an AND here. So as long as this is false, the whole statement is false. So the while loop will exit, and then you move on to the next instruction here. And here you check the value of I. If I is less than or equal to n, then you say that the location is equal to I. Okay? But if I is greater than n, so that means that you went through the whole list of books by iterating the value of I from I to n, and this wasn't the case, and then you increment the value of I by 1, I will be equal to n plus 1. So since I is equal to n plus 1, because you didn't find the book in the bookshelf, then you set the location to 0. That means if the location is 0, that means that the book is not in the bookshelf. So during the synchronous session, we'll do an example and we'll follow up the steps of the algorithm, and it will become more clear. Now, what would happen if you knew as a fact that the books in your bookshelf were sorted by alphabetical order? Well, things will be much more easier. It will be easier to know, faster to know whether the book is in the bookshelf or not. As you can imagine, the input is going to change. So here the change in the input is that the sequence A1, A2 up to AN are increasing, or in alphabetical order, you can say, or in any order within some context. So the algorithm here proceeds by splitting in half the bookshelf. Right, so you split the bookshelves in half, and then depending on what you're looking for, you know where to look, on the right-hand side or left-hand side. And then you compare. Is what I'm looking for equal to the first element of the half that I'm looking at? If the answer is no, then you split that half again in half. Okay? And then you compare again. And you keep moving on in the same fashion until you find what you're looking for. Things are much easier this way. During the synchronous session, we'll do an example with the binary search algorithm.